Okay, the next little bit that we're going to have a look at is really a subset of linear functions, and that is between variables that are directly proportional. So just a little bit of terminology. The symbol for directly proportional is this one, which looks a little bit like an infinity sign with the back cut off it, or a little fish with a blunt nose. And we usually write y is proportional to x. And there's three ways to tell if two variables are directly proportional, and they are these. So if we multiply one variable by a certain number, it results in the other variable being multiplied by the same number. For example, if we double x, then if it's directly proportional, then we would see a result of double y. Going back to have a look at our taxi example up here, we can see that if we double 1 to get 2 in our x variable, we don't actually double 6 to get 12. We're only adding 2 to make it 8. You can also check if we triple it to get 3. 6 tripled is not 10, so we can say that the taxi scenario is not directly proportional. The second one, and it's at least one of these. It doesn't have to be all three. It can be any one, and that's enough. The next one is that the graph is a straight line and goes through 0, 0. So I guess the big distinction here is that it goes through 0, 0. You can see that the equation, the graph of the taxi scenario does not go through 0, 0. So there's another indication that it's not directly proportional. And the variables are related by the equation y equals kx, where k is a constant multiplying the x, and that is known as the proportionality constant. Again, with our taxi scenario, we've got the equation c equals 2d plus 4. This plus 4 tells us that it's not directly proportional. Pardon me. So if we're going to find the proportionality constant, so if two variables are directly proportional, then going from the equation y equals kx, we can rearrange that to give us k equals, just divide by x on both sides, k equals y on x. So we can find the proportionality constant from any pair of coordinates, x and y. The other way that we can do it is by finding the slope of the line, assuming that it's a straight line going through 0, 0. Here's something for you to do. Think and write. Answer question 2 in the discussion box on page 13. So have a look at that, and you can write down your answer either in your booklet or in your notebook. Another little bit of terminology. If a graph is a straight line but does not go through 0, 0, then it's called non-proportional. So the taxi scenario that we've been looking at is an example of non-proportional. The cost is non-proportional to the distance travelled. All right, let's have a look at an example. So Neville requires 8 buttons for each shirt that he makes. Show that B, the number of buttons required, is directly proportional to S, the number of shirts that Neville makes. So we would start by making a table of values. Our x, or our independent variable, which is the number of shirts, goes on the top line, and our dependent variable, which is the number of buttons, goes on the bottom line. And let's say that Neville makes 0, 1, 2, 3, 4 shirts. If he makes 0 shirts, it makes sense that he needs 0 buttons. He makes 1 shirt, he needs 8. 2 shirts, 16, 3 shirts, 24, 4 shirts, he'll need 32 buttons. When we plot those points on a set of axes, our first point is 0, 0, which should be our first hint that this may be directly proportional. Our second point is 1, 8, 2, 16, 3, 24, 4, 32, and so on. Then we use a ruler to join them up with a straight line, and you can see that we have this nice straight line that goes through 0, 0. So the graph of the number of buttons versus the number of shirts is a straight line through 0, 0, that's enough evidence. Another piece of evidence is that a double in the number of shirts results in a double of the number of buttons. So therefore, S is directly proportional to B, and we would write it as S is directly proportional to B. The second question says find the proportionality constant, and you can either do that through the slope of the line. So rise over run, so just pick 2 points and find the rise and the run. So the rise is going to be 8 and the run is 1. So 8 over 1 is 8, so K equals 8. That's one way that you can do it. You don't have to do both of them, I'm just showing you. The other way is, remember that K equals the Y coordinate divided by the X coordinate. So choose any pair. 32 divided by 4 is 8. 24 divided by 3 is 8. 8 divided by 1 is 8, and so on. Therefore, K equals 8. And then lastly, find the equation. Remember, we're talking about Y equals Kx. In this case, Y is B, the number of buttons, equals the proportionality constant, which is 8, times our X variable, our independent variable, which is S. So the number of buttons required is 8 times the number of shirts required. And that's it. There's some exercises in 1A for you to do.